Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 26 of 2015 JEE Advanced Physics paper. So let us move to solve question number 26. Students, let us solve this question number 26. In the following circuit, the current through the resistor R of 2 ohm is 1 ampere, I ampere. The value of I is, the value of I in this 2 ohm resistor, what is the current that is flowing through this? This I is asked. Now, we have read about the Wheatstone bridge network. The Wheatstone bridge network consists of 4 resistors in the 4 arms of a rectangular shape and one more resistor in the diagonal of the rectangle, and in the other diagonal we connect a battery. We think of that, then if you see this one, suppose I call this as A, this point as B and this point as C. If you only think of this A, B, C, A, this is basically a Wheatstone bridge. I draw it here, you can see that this is 1 ohm here, this is 2 ohm there, and 4 ohm here, and then 2 ohm here. So it is 2, this 1, it is 2, it is 4, and from B, this is A, this is B, this is C, and there is a point here. In between this, there is one resistor connected, which is 8 ohm. Now, E and these two ends are taken out. Terminal A is taken out and C also taken out. Like the current is flowing like that. You can easily see that this is because the current whatever will enter here, some current will come out from here. This structure is basically a Wheatstone bridge. These two are the upper arms and these two are the lower arms, and this is like if I extend this down, this will become 2 will become here like this, and 4 will become like that, and this is 2. So this is a balanced Wheatstone bridge. So ABCA is a balanced Wheatstone bridge. So therefore, in case of a balanced Wheatstone bridge, this 8 is to be removed. We remove this part and redraw the picture. And this AC together forming Wheatstone bridge will have effective resistance. If this is withdrawn, this diagram will look like this diagram will look like this is A, this is 1, this is 2, and here it is 2, and here it is 4. This is taken out. This is our A and this is our C. So the upper arm is 3 and the lower arm is 6. This together is 3 and these two together is 6, and these two are in parallel. So 3 parallel with 6. So the equivalent resistance across AC is equal to this AC together. I'm not considering this one, only this part is product divided by sum, that is 9, 3 3s are 9 and 3 2s are 6, so it is total equal to 2. So this whole bunch of these resistors are removed and only I will connect one single resistance of 2 ohm. Then that circuit will be simplified. So let me draw the diagram. It was 6.5 volt over here, and this is 2 ohm resistance, and here I have 8, and here I have 12. This is 8, this is 12, and there is 10 ohm connected here, and this is point A, this is point C, that earlier we used to have 4 ohm here, and it is connected directly like that. So you can see that 6, 10, 4, 12, 2, 6, 4, this is 4, 6, 4, 10, this is 6, this is not 8, this is 6, so this is 6. So these are the things, and you can see that in place of A and C, I have already found the equivalent resistance, that is 2. I'll connect between AC 2 ohm. So this is the equivalent resistance I found, which is 2. So this being 6, this is 2, this is 6, this is 12, this is 10, this is 4, this is 2, and this is 2 ohm, 6 ohm. Now what happens is that this one, you can see that this, if I name this as D, if you look at A and D, this is again a Wheatstone bridge. AC is 1 arm. I can pull this down here, D point, then CD, then pull this down here, this, then that. So these 2 arms are the lower arms, these 2 are the upper arms, this is the diagonal, where generally we used to connect a galvanometer. So this upper arms ratio is 2:4, and the lower arms ratio is 6:12. So this is half, this is also half, that means this is balanced Wheatstone bridge. So I'll call this A, C, you can call this as E, A, C, E, D, A. Is a balanced Wheatstone bridge. So therefore this part is removed. So remove this part. If I remove this part, then these 4, 2 and 4 will be left, and this side it is 6 and 12 will be left, and this is connected like that. These are the terminals. So these are the 2 and 4 in series, that is 6. These 2 is 6, these 2 are in series, that is 18. So this 6 of here and 18 of here, they are in parallel. These are the 2 parallel connections. So 6 and 18 are in parallel combinations. So the equal resistance between A and D, this is A and this is D, and RAD is this one, that is product divided by sum, that is 24. 6 for the 6 for the 24, and this is 2 is 9, 2 is 2, this is 4.5. So between these two I will have to connect, so I'll remove this and connect a equal resistance of 4.5. So this diagram I will draw again. This is simplified, this is 6.5 volt, there is a 2 ohm resistor here. Now this is A point, this is D point, and there is no connection over here, and this between A and D we have got RAD equivalent resistance, which is 4.5 ohm. This is 2 ohm, which is 4.5 ohm. Now whatever current comes in goes in through both the resistors, so they are in series. Because they are in series, so therefore let I is the current flowing. So RAD is 4.5 ohm. I'll connect here 4.5. So this current is basically the voltage here you are applying divided by the equivalent resistance. These two resistance in series, so it is 6.5. So this is ampere, that is 1 amps. So finally we got that I equals to on. That means in this case the value of I flowing through 2 ohm resistor is how much, and we got this coming out to be 1 ampere. So answer to this question is 1 ampere. That is the answer. Okay, thank you.